Hello everyone, welcome back to Vita, where we explore the world of data and its impacts on improving our lives and decision making. I'm Mari, and this is episode 5 of our series, Unlocking Data Insights for Beginners. In our last episode, we took a deep dive into data modeling in Power BI, learning how to structure a relationship between tables, understanding primary and foreign keys, and create an efficient data model for analysis. Today we are moving on to something even more exciting like DAX, unleashing the power of calculation in Power BI. In this video, we will introduce you to data analysis expression DAX, the formula language behind Power BI. With DAX, you can perform advanced calculations, unlock dynamic insights, and build reports that go beyond the basics. Whenever you are creating calculated columns or measures, DAX is your key to transforming raw data into actionable results. By the end of this episode, you will be understanding the fundamentals of DAX, how it works, and how to use it efficiently in Power BI. Let's get started. In this episode, we will be covering a well-structured outline to help you get comfortable within DAX and its powerful capabilities. Here is what we will explore together. We will start with basics. What is DAX and why it's such a game changer for Power BI users? A step-by-step breakdown on how DAX formulas are written, including the building blocks you need to create accurate calculations. One of the most common questions for beginners. We will dive into when to use each and how they impact your data model and reports. And context is everything in DAX. We will demystify these two crucial concepts to ensure EU formulas work as expected. I mean raw contexts and filter contexts. Before we dive into hands-on practice, it's important to first understand the theory. Once you have the fundamental knowledge, in the next video we will explore practical examples of DAX in action, applying real-world calculation to reinforce your understanding. Finally, we will summarize everything we have covered to give a clear roadmap of DAX fundamentals. By the end of this episode, you will have the confidence to start using DAX in your own Power BI project. DAX, or Data Analysis Expression, is a formula expression language at the heart of Power BI analysis service and Power Pivot in Excel. It allows you to create formulas using functions, operations, and values to perform advanced calculations and queries on data in related tables and columns within tabular data model. Why is DAX so essential? It enables you to define custom calculations for your reports, turning raw data into actionable insights and dynamic analysis. In Power BI, we core components include tables, columns, measures, and visuals. DAX plays a crucial role in creating two key elements. I mean calculated columns and measures. Calculated columns used to add additional fields to your tables based on your data. And measure is dynamic calculation used in your report to summarize, analyze, and visualize data. By mastering DAX, you can unlock the full potential of Power BI and take your report to the next level. DAX syntax refers to the set of rules that govern how DAX formulas are written and structured. A DAX formula always starts with an equation sign. DAX formula consists of function name, arguments, operations, and constants. Function name is the name of DAX function you wish to use. Arguments is inputs to the functions, such as columns, tables, and expressions. Operation is like the symbol that specifies the type of calculation to perform, like plus, minus, and so on. And constant, which is options and which is fixed values used within the formula. Understanding how each of these elements work together helps us create powerful and flexible formulas. For example, profit margin. Profit margin measure formula divide sales revenue minus 1,000 sales revenue. In this formula, we have divide, and this is its function name. Sales revenue minus 1,000 and sales revenue are the arguments. Minus and are the operations, and 1,000 is a constant. The formula calculates the profit margin by dividing the difference between revenues and a constant value 1,000 by the total revenue, using the divide function to handle divisions and answer proper calculations. Let's start about difference calculated columns versus measures. Calculated columns are new columns adding to an existing tables in your data model. Each value in your column is calculated row by row, which means that for each row of data, formula is applied to compute a result. For example, if you want to calculate the profit for each sale, you would subtract the cost from the revenue for each row. Calculated columns are evaluated once when data is loaded or refreshed, and their value are stored in the model. And measures. Measures, on the other hand, are dynamic calculations that are based on the context of the data. These calculations are stored in the tables, but are evaluated when a query is run or when a visual is rendering in Power BI. Measures are calculated on the fly based on the filters or slicers applied for your report. For instance, if you want to calculate the total sales for the formula, may sum up all revenue value based on the current filter context, like specific region or time period. Calculated column in DAX operated in what is known as row context. This means that for every row in your data model, the calculation will be performed independently. The result is computed for each row and stored in the data model as part of the table. For instance, if you have a column for sales revenue and sales cost, and you want to calculate the profit for each row, a calculated column would subtract the cost from the revenue for each row. Measures operate in filter context, which means the result of the measures depend on the filters or aggregations that applied to the data. Measures are recalculated dynamically every time the data context changes, such as filtering for a specific product category or selected data ranges. This makes measure particularly powerful for aggregation data, calculating the average, sums, or percentage dynamically based on the user interactions with the report. One key difference between calculated columns and measures is how they are stored. Calculated columns are physically stored in the data model as part of the tables. When you create a calculated column, its value are persist in the model and occupy space in your table itself. This makes calculated columns suitable for situations where you need to create new data points for every row in your datasets. Unlike calculated columns, measures are not stored in data model. Instead, they are calculated on the fly when the data is queried or visualized. Measures do not take any additional storage space in our data models, and they are recalculated every time the data is filtering or refreshed. This allows measure to handle aggregations and dynamic calculations efficiently. Use cases when we need to use calculated columns and measures. There are some useful when you to create new data points on row by basis. For example, if you need to categorize data or create additional attributes for each row. For example, grouping customers into high value or low value categories based on their total spend. You need to use calculated columns. Calculated columns would be right choice. They are often used for creating data points that can be refreshed in visuals or other calculations. Measures are ideal for aggregation data on performing summary statistics. For instance, If you need to calculate the total sales for a given time period or the average profit margin, you could use measure. Measures are designed for calculations that depend on a filter or context, such as summing revenue, counting growth, or calculated percentages. Calculated columns example contains, for example, you want to have type sales revenue and sales cost column, and you have to want calculate profit for each sales. You need to use calculated form. And if you want to dynamic calculation, for example, sum revenue, and user needs to select, for example, region, product category, or other, you need to use measures. And finally, recalculation steps. Calculated columns are recalculated when the data model is refreshed or when the underlying data changes. Since recalculated columns are stored in the model and updated to the data, such as importing new data or updating existing value, we trigger a recalculation of the calculated columns. And measure, on the other hand, are recalculated every time a report is filtered or refreshed. The recalculations happens dynamically based on the context in which the measure is being used. For instance, if you are user and user applies a filter for a specific year, the total sales measure will calculate the sum of sales only for the specific years. Measures are recalculated whenever the visual or report is updated, ensuring that the result always reflects the current state of the data. And summary. In summary, calculated columns are used for you. Calculated columns are used when you need to add data on row by row basis and need that data to be stored in the model. They work in a row context and are recalculated when data is refreshed. Measure, on the other hand, are dynamic calculations that depend on the filter context and are recalculated every time the report or visual updated. Measures are particularly useful for aggregation and summary statistics like totals, average, and percentages. Both tools are essential for building insightful Power BI reports and dashboards, and understanding when to use each one is key to leverage DAX efficiently. In this slide, we will compare two key concepts in DAX: row context and filter context. These are fundamental in understanding how DAX formula work and are essentials when creating accurate and dynamic calculation in Power BI. Row context refer to the context where each individual row in a table is evaluated. It's used when working with calculated column and iterator functions like sums. Row context allows you to perform calculation on per row basis, which means each row is evaluated identically based on its data. The context is automatically managed for each row and does not require additional management from users. For example, if you create a calculated column that subtracts the cost from the revenue for each row in a sales table, the row context ensures that the calculation is applied for each row individually. Filter context is a bit different. It refers to the context created by filtering in report tables or slicers. In Power BI, this is commonly used when creating measures, dynamic calculations, or when working with calculate function. Filter context is not specific, row specific. It aggregates data based on the filters applied in the report or visualizations. For example, if you have filter on a data range or a slicer that limits the data for a specific region, the filter context will calculate the measure based on the selection considering only the filter data. What is key difference and where it applies? Both row context is commonly used in calculated columns and iterate function like summix, where each row is independently calculated. Filter context on the other hand, is used in measure dynamic calculations and when you use function like calculate, where the entire table or subtract of the data is affected by the filters. Row context is influenced by the row level within the table itself. Filter context, however, is influenced by the filters that are applied to the report, tables, visuals, or slicers. Row context is automatically managed by DAX for each row during calculation, and filter context, however, is controlled by the report context, which means that filters and slicers you apply in your report dynamically adjust how the data is evaluated. Understanding both row context and filter context is critical for creating accurate and dynamic DAX calculation. The row context operates at each individual row, while the filter context aggregates data based on the user-defined filters. This context helps ensure that your calculation adjusts correctly when interacting with data in Power BI. As we continue this course, we will dive deep into how both contexts interact and how to use them to create more advanced calculations. This topic is very important and we will come back to several times throughout the course, as it lays the fundamental for mastering DAX and achieving power insights in Power BI. Now let's recap what we will covering so far. In the next video, we will doing practical sessions. DAX is formula language used in Power BI and Excel for calculation, and it's made up of functions, arguments, and operations and constants that help us perform advanced analysis. We have also learned the key difference between calculated columns and measures. Calculated columns perform row-level calculations and are stored in the data model, while measures are dynamic calculations that are computed on demand depending on the context. Speaking of context, we have discussed the two main types: row context, which evaluates data row by row, and filter context, which is influenced by filter or slicer applied to the report. Both plays a crucial role in ensuring all our calculations are accurate and relevant to the data being reviewed. We'll also explore the difference between these two contexts on the whiteboard. And that's all for today's videos. I hope you have a better understanding of that, its syntax, and how it helps you to create powerful calculation in Power BI. If you have any questions, feel free to reach out. You can contact me throughout the details on the screen, and don't forget to follow the Vita for more insight of data and analysis.